All right. So what we wanted to look at today is just a few examples where it's a little more complicated as far as what happens with integration by parts and U sub. Tomorrow we're going to go ahead and move into trig integrals, and that'll take us into next week. But I want to look at this integral to begin with. So let's say I've got the integral of cosine square root x over the square root of x dx. And then let's also look at the integral cosine square root of x dx. So we'll do both of these problems. One of them is pretty straightforward and one of them is relatively complicated. The first one you can do with just U substitution. What would you do to set that up if you're going to do just U substitution on the first one? It doesn't require parts or anything more advanced, just U sub. Any ideas?
Set U equal to the square root of x.
Yeah, so we're going to let U equal the square root of x. And if we do that, then that's really x to the 1/2. So then du is 1/2 x to the negative 1/2 dx, which is 1 over 2 square root of x dx. So we can rewrite this problem as cosine square root of x times 1 over the square root of x dx. And then we could probably combine these steps, but I need a 2 in the denominator of that fraction. But in order to do that, what I've really done is multiplied by 1/2. So then outside I multiplied by 2 in order to kind of cancel that out. Does that make sense, everybody? All right, and so then I get 2 integral cosine u du, which then is 2 sine u plus c, and that's 2 sine of the square root of x plus c. And we've done problems like that before. We may have done this problem before. But it's relatively straightforward with U sub. Does everybody follow that? Any questions on that problem? It's okay if we don't remember something. Just
I have a question.
Sure. Yeah.
So for like crowd marks and like future exams, are you cool with us like skipping a few steps now with U sub?
100%. Yeah. Yeah. I mean, you probably shouldn't jump just to the final answer. But yeah, I talked to a few people. We were going over tests on Monday. Don't put extra steps in to make me happy. Okay. So like, you know, I don't want you to spend extra time writing something that you don't need to write to figure this problem out. It needs to be clear that you didn't just go type it on a calculator, but like, as long as you're showing the basic steps, you're completely fine. I'm not out to get you cheating. Does that make sense? Like, we're not trying to look for you cheating on a test. So like, don't worry about adding something in for me. You show what you need to show. Fair enough? Okay. Other questions? All right. So on the second problem, we're going to do actually something similar. And so it's not clear that this is going to work at first, but we're going to have to cheat a lot to make this work. And so we're going to start by letting u equal square root of x, and du then is 1/2 x to the negative 1/2 dx, which is then 1 over 2 square root of x dx. And so I can go through and do the same thing. Well, no, I'm sorry, I cannot. So let's talk about that. But we're going to try to force this to work. And probably up till now, we would have said, okay, that's actually not going to work. And we're going to see why it does here. So what I want to do is I want to get, my bad, let's leave a little bit more space. I want to get 1 over 2 square root of x in there. And I cannot just randomly throw that in. To get the 1 over 2, that's easy to deal with because I can put the 2 out there, and that's okay. What we cannot do is multiply outside by the square root of x, but we can multiply inside by the square root of x. And so it's weird to do that. It's not something we've probably done before, but to kind of force that in order to get the 1 over 2, I can put a 2 out here. In order to get the 1 over the square root of x, I can put a square root of x, but I cannot pull that out. Is everybody clear why I'm allowed to do what I just did? It's not necessarily clear why it's going to work, but are we clear that it's okay? Everybody good? Okay, now the reason it is going to work is because this stuff at the end, that's du. This is cosine of u, but then what's this?
U.
That's u. So I can rewrite the problem as 2 integral u cosine u du, and maybe that's not the form we thought we were going to get it into. We were probably, like, when we're setting this up, we're probably thinking, okay, cosine u du, like up here. That's not what happens. We get u cosine u, which is not a basic form, but what can we do so that this will now work out?
Parts.
Yeah, we can do parts on this. So we're going to set up integration by parts, and I'm going to do that. I'm going to use different letters because we've already used the letter u within the actual problem. So instead of u and dv, we're going to say, okay, v is u and dw is cosine u du. dv then is 1 du, and w is sine of u. So now normally it's uv, but this time it's vw. So we get u sine u minus the integral of w dv. So that's minus the integral sine u du. Is everybody clear what happened there? Any questions on what's going on? Okay, so we're going to take a step to distribute the 2. And now the antiderivative of sine is negative cosine, which gets us plus 2 cosine u there. And now u the entire time has been the square root of x. So we replace u with the square root of x, and we get 2 square root of x sine square root of x plus 2 cosine square root of x plus c. And that's the answer. All right, any questions on that problem? So it's a real weird problem at first, but it's a technique we can do. So like you can insert variables as long as you counteract that, but you cannot pull the variables out. So you have to be able to deal with this inside of here. And because it ended up being u cosine u, that was a problem we could handle using integration by parts. We could not have done this before we talked about integration by parts, but now that we know how to deal with this, we can. Everybody clear on that? Any questions? Okay. So I want to look at another problem. So first of all, the integral of sine square root of x should be pretty clear that that's going to be almost identical to this. So everybody see that? And also e to the square root of x works out a lot like this. And so those are problems you'll probably see on the homework. It might be cosine again, but all 3 of those work basically the same way. I want to look at, like up here, we had u sub that worked, and then we kind of forced it here. We're going to look at another one where this problem would be easy if we had something else there, but it's not as easy here because there's no like over x, like there's no 1 over x in the problem. So we get what I mean? So like ideally u would be log x and du would be 1 over x, and that's not going to work, or at least it's not going to work well from what we've got written there. We're going to approach this problem in two different ways. So we're going to do this problem two ways, and you can pick the way that you like better. But based on what we did in the last problem, given that, okay, we were kind of able to force this approach to work, what do you think maybe we would want to try on this problem if we could get the same type of thing to work out like we did before? What do you guys think?
Make u equal to natural log x.
Yeah. So if we did the same thing we did before, we would let u equal natural log x. And then if we do that, du is 1 over x dx. And now I want you to do the next step or two and kind of force that 1 over x in there. And see if we can figure out what makes this one more challenging than the last one. Okay, so we need on this one to multiply by 1 over x. So we need that for the du. But in order to do that, we also have to multiply by its reciprocal, which is just x. You cannot pull the x out of the integral because it's a variable. So we have to put it inside the integral. So our steps should look like this. So we've got sine of u du, but we have this extra x here. So everybody see that? Now, it turns out we can handle this. But I want to show a different approach, and then we're going to come back and finish this problem. Does anyone know what to do from here? Or actually, maybe a better question is, why is this harder than what we've got back up here? So like when we got to this stage here, why did this work out so well? What happened?
Because the square root of x was u.
Yeah.
Another one, it's not like that.
Right. This square root of x was u. And down here, u is log x, but this is not log x. So like it's not now u sine of u du, which would be ideal. Like I said, we can work around that, but it's not as straightforward. Does everybody see that? Okay. And so another option on this problem, and we'll come back and do it that way, but another option on this problem is to let u equal basically the whole thing and let dv equal 1 dx. So kind of like we were doing with inverse tangent yesterday or just log x yesterday. This is an option that you can try, and if it works out to be something we can handle, then we can do that. So if I do this setup, du is cosine of natural log x, but then what? Times something.
1 over x.
Yeah, times 1 over x because of the chain rule. And so we get cosine of log x times 1 over x dx. And then v is x because it's the antiderivative of 1 dx. Does that make sense to everybody? Okay, so now we go uv. So uv is x sine of natural log x minus v du. But if I multiply these together, what simplification happens real quickly if I multiply v times du? V times
Just
du.
be cosine of natural log x.
Yeah, you just get cosine of natural log x dx because the x and the 1 over x cancel. Does everybody follow that? Why that is? Any questions? Okay, so what do you think's going to happen, or what do you think we should now do?
If you do it again, it's probably going to end up in its original integral.
Exactly right. So if you do basically the same thing again, you're going to get back to this starting integral, which is one that cycles back to the original like we did yesterday, where we're going to like solve an equation. So I'll do that in a different color just to make it clear when we're looking at it. But let's do parts again. This time we're going to get u equal to cosine of log x. dv is going to equal dx. du then is negative sine log x times 1 over x dx, and v is x. So now this is x sine log x minus the integration by parts formula, which is x cosine of log x minus the integral of v du. When I do v du, we have a negative that comes out, which is why this is plus at this stage. And then the x's cancel, so we get plus the integral of sine natural log x. But that's all within brackets. Got to be real careful with the signs. But at this stage, this is a plus sign. Now we're going to take a step to distribute the negative. So we get x sine natural log x minus x cosine of natural log x minus the integral of sine natural log x dx. And how do we know at this stage we should stop doing integration by parts? Because it was kind of clear we were just going to keep going forever at this point. But why stop here instead of before? Like we could keep doing parts as long as we want. It's just going to keep going, right? Why stop now? What do you guys think?
Because you have the original.
Yeah, it's exactly the original. Is that what you were saying too, Rachel? My bad, everybody's talking at the same time. Okay, you're good. So this is exactly the same as the original. So, okay, so that means we stop with that work. Not that it's wrong, we need all that. But we say, okay, well now the original integral is equal to that last line. So it's equal to x sine log x minus x cosine natural log x minus sine of minus the integral of sine of natural log x dx. And now we're going to solve for that integral. So what should I do with this equation? What should be the first thing I do now?
Add the integral over to the other side.
Yeah, we're going to add the integral over to the other side, or add it to both sides, which means we're going to get 2 integral sine natural log x dx equals x sine natural log x minus x cosine natural log x. Does that make sense to everybody? We're now going to divide by 2, which is the same as multiplying by 1/2. So we can say, okay, the integral that we were looking for, sine of natural log x dx, is equal to 1/2 x sine of natural log x minus 1/2 x cosine of natural log x. And then there could have been a plus c. Probably the best stage to throw in the plus c would be on the step right before that. Once there's no longer an integral on both sides, it's kind of understood there's a plus c as part of this, but now that it's gone, there could be a plus c remaining. And so it probably should go there, but not a huge deal if you don't throw it in until the end. Okay? Everybody follow that? It's kind of a weird problem. It's one where maybe it's not clear that that's going to work to begin with, just like the first one we were doing, or I guess the second one we were doing. It turns out it works, but you have to be pretty creative to get this solution to work. You can approach this problem the way that we started up here. So I'm going to get us started on this approach, and then we're going to see what happens. So if you start, so on this problem, what we did is we started with parts, and then we ended up doing parts twice, and then we're able to do the integral. Here, we're going to start with u sub, or we did start with u sub. What you have to do to get this to work is you have to remember that e to the natural log x is equal to x. Or you have to solve this equation for x and get that x is e to the, I'm sorry, yeah, x is equal to e to the u. So either way, if we remember e to the natural log x is equal to x, we can rewrite this problem as e to the natural log x, and then I'll try to keep the colors matching what we had up there so it's clear what we were doing. But sine of natural log x times, and then 1 over x dx. So if we remember that property, that e, or the fact that e and natural log are inverses, that if you do this, this is x, we can replace this with this. And either way, what happens is we get e to the u, and then sine of u, and I'm just going to do this all in red, sine of u du. And now that's an integration by parts that then cycles. Or if you solve this for x like we did on some of the problems before the first exam, you can jump from here to here. But either way, you get it to this point. Does everybody see that? What's going on? Okay, I think it's harder to know to do that. So like, I think most of us, or if I was working this out and hadn't done it before, I might get stuck here and not think what to do. But if you think what to do here, now this is like a problem we were doing with yesterday's lecture, where you do parts twice and it cycles back. You end up having to do all this anyway. It just looks different because this is a slightly easier integral setup than this was to begin with, but you do parts twice and it cycles back to the beginning. You will end up with the exact same answer by doing it this way, but there's a good bit of work to do from here. Does that make sense to everybody? Questions on what we're doing? Okay, and so I would recommend doing a problem like this way. The problem back here, I believe you could get it to work if you start with parts rather than u sub. So like if you did parts where u is equal to cosine of square root of x and dv equals dx, you can probably get it to work out. But I think that approach on this problem is much more difficult than the approach we ended up using. Okay, so on this one, it's easier to start with u sub. On this one, I think it's easier to start with parts. Okay, all right, so we'll look at another one. And so we're gonna go with the integral of x to okay, so we're going to try this problem, and I actually would like you guys to try an approach on this. So take a second and see if you could figure out something that would work, and then check with me in a minute and see if we end up doing the same thing. But I'm going to give you a minute to think about it and see if you can get something to work out. Hey, Google, set a timer for 1 minute.
Okay, 1 minute. Starting now.
Hey Google, how much time's left on the timer?
T minus
man.
9 seconds.
I thought I was on mute. My bad. You heard my timer going. All right, my bad, you guys. I thought I was on mute. Okay, anyone get an approach that worked here?
Yeah.
Okay, what'd you do?
I set u equal to x cubed.
Okay, good. So if we let u equal x cubed, du is then 3x squared. And then, okay, what'd you do from there? Or somebody else, what should we do from there?
Well, x to the fifth is just x cubed times x squared. So you can kind of
Okay.
split that up and make it like, you can split that up and then by multiplying by 2 and then 1/2 on the outside, you can make it u du.
Okay,
We
sweet.
end up with,
So we're going to split it like that, right, you guys? So this is for du. And then I think you meant 3 1/3, right? So because we want 3x squared here. So then we're going to put 3 here and 1/3 out here. And now somebody else, why does that work? What should we now do? How should I rewrite this?
It should just become u cosine u du.
Perfect. So this is now u cosine u du. Any questions to that point? Sounds like several of us got that. Is that what we're getting? All right, that's good. Somebody else who hasn't talked on this problem, what do we now do with this?
You would just do parts.
Yeah, so we just do integration by parts. So we're going to set, since we already used the letter u, let's use different letters. So v is going to be u, dw is going to be cosine u du, and then dv is 1 du, and w is sine of u. So we get 1/3 times the integration by parts formula, which for this is vw minus w dv, but the integral of that, so minus the integral sine u du. Take a step to distribute the 1/3. Oops. Sine of u minus 1/3 integral sine u du. And now the integral of sine u is negative cosine, so we get 1 plus 1/3 cosine u plus c, and now u is x cubed. So we get 1/3 x cubed sine of x cubed plus 1/3 cosine of x cubed plus c. Does everybody follow that, what we're doing? Okay. Any questions on that? Pretty straightforward. All right. Okay, so I don't want to do this problem, but I want to talk about how we'd set it up. So if I have x to the 11th, e to the x to the 4th, e to the x to the 4th, dx, then what could we do to start that problem? What approach do you think might work to start that? So again, maybe not obvious that it's going to work, but what would be the most obvious thing to maybe think to start?
Let x or u equal x to the 4th.
Yeah, so like we'd probably try to let u equal x to the 4th, and most of the time we probably would have said that's not going to work real well, but if we do that, now we've got du equals 4x cubed. And so I can get the x cubed over there, and that leaves x to the 8th and then I can get a 4 and a 1/4 to get us the du that we want. So now, before we go on, we should now be able to figure out, okay, is this going to work or not? And so what do you guys think? Is it going to work?
Yes.
Yeah. And what about this means that it's going to work?
That u is x to the 4th, so you can break up x to the 8th.
Yeah. So how should I rewrite this? As u what?
U squared.
Squared. Yeah. So I can then rewrite it as u squared e to the u du, which is not like the most straightforward integral ever, but it is parts, and it's a relatively straightforward parts that you have to do twice. Does that make sense to everybody? You guys good? Now, what if this had been, instead of x to the 8th, x to the 7th at that stage? Would the same approach work well? No. And so the fact that u is x to the 4th, and then this power ended up as a multiple of 4, that's what allowed this to work. Same thing back here. The fact that this was x cubed, because this was 3, if this had been 3, 6, 9, or 12, or so on, if this had been a nice multiple of 3 as this power of x, then we're going to get u to an integer power cosine u, which we can then handle. Does that make sense to everybody? If this weren't a nice multiple of 3 after separating that x squared, it doesn't work very well. And so we'd have to try something else, or maybe it wouldn't be possible. Does that everybody follow it? Any questions so far? I think these two are actually more straightforward than the first two sets we were doing. I think these are a little bigger. We have some more stuff to talk about today, but I want to talk real quick about the next assignment. So the next homework assignment that you're going to see is called Integration by Parts 3. And it's just kind of some of these where you have to be a little bit more creative. You already had some on Integration by Parts 2 where they were relatively tricky. Integration by Parts 3 is another homework set. Not too many. I think it's maybe 10 problems, maybe 12, something like that. But some of these where you have to be a little bit creative, they're not, well, they're creative. So you have to take some time on those. Okay, so that's Integration by Parts 3. They're not all integration by parts. You might have to use u sub. Probably most of them end up being parts, but some of those are mixed in. I actually want to move on to another class of problems that we'll work on a little bit right now, and then we're going to work on a lot tomorrow. But I want to look at this problem, and we're going to look at two approaches to this problem. So if I have sine, let's do sine to the 5th x cosine to the 6th x dx. And then again, the same problem. So sine to the 5th x cosine to the 6th x dx. Okay, so this is an example of a class of problems that we're going to call powers of sine and cosine, which is not some code word. It's pretty clear why we would call it that. So this is this set of problems called powers of sine and cosine. And on most problems that involve powers of sine and cosine, there are two approaches, and we would like one of them to work. Okay, so the two approaches we would like to work are to let u equal sine x, or to let u equal cosine x. Now, depending on the problem, sometimes u equals sine x works. Sometimes u equals cosine x works. Sometimes they both will work and it doesn't matter. And sometimes neither of them work. And so what we want to figure out is how could we know by looking at this which approach works, or if neither approach works. And so we're going to try to figure that out now, and then we're going to do a bunch of examples like this tomorrow. Does that make sense to everybody? Okay, so if I'm going to use this, and when I'm doing these setups, I'm doing u equals sine x or u equals cosine x just as u substitution, not as integration by parts. Okay, so I'm doing it just as u substitution. So if u is sine x, what should I then do? So obviously du then would be what? Cosine x dx, right? Okay, and so I'm going to try to create du at the end of the problem. And the thought process is actually not a lot different from this. We're going to separate out what we need to get the du. So like here we needed x cubed, so we separated out 3 of them and it left 8. So the same thing happens here. Here I need cosine. So let's put everything that's already in the problem in black. We're not going to touch the sine to the 5th x, and we're not going to touch the dx. But what we are going to do is put a factor of cosine next to the dx. So we're going to put this there, and then what's left that I need to put here if I've taken one factor of cosine for the du? What should I put here? What do you guys think?
Cosine of 5x.
Yeah, cosine to the 5th. So 5 factors of cosine there. And the idea is, remember, cosine, like when we use that notation like this means cosine x all raised to the 5th power. So when it's a 6 there, it's like there's 6 of them there. So there's 6 factors of cosine. So I take one of them over here, and there are 5 left over. Does that make sense to everybody? Everybody clear? Okay, so this part is the du. And now we want to get everything written in terms of u. So I want to rewrite all of this in terms of u, kind of like what we were doing on those problems before, but we got to figure out how to write it in terms of u. So this part is already just u to the 5th. Does everybody see that? Okay, but cosine, we need to figure out how to write in terms of u. We have an identity from trig that sine squared plus cosine squared is equal to 1. Whoops, cosine squared of x is equal to 1. Now that identity allows you to rewrite sine in terms of cosine, and it allows you to rewrite cosine in terms of sine. So here, I want to rewrite cosine to the 5th in terms of sine, and I'm going to do the scratch work for that on the side. So cosine to the 5th is the same thing as cosine squared to what power? So cosine to the 5th is the same as cosine squared raised to what power? What power should I put outside those brackets so that this is the same?
5 over 2.
5 over 2, yeah. Does everybody see why that's true? So when you do a power to a power, you multiply. So cosine to the 5th is the same as cosine squared to the 5 halves because 2 times 5 halves is 5. Why would I choose to write it with a cosine squared here? So this is not always going to be 5 halves, but we are always going to want squared here. Why? Based on what we've got up here. What's cosine squared the same as?
1 minus sine squared x.
1 minus sine squared x. So cosine to the 5th is the same as 1 minus sine squared to the 5 halves. That means I can rewrite this problem as sine to the 5th x times 1 minus sine squared x to the 5 halves times cosine x dx. This stuff up here at the top and on the right, that's stuff we don't normally need to write out. But if it helps to write this out, you're welcome to. Just do that on the side. Just we want to go from here to here. Does everybody follow what's happening so far? Okay, now the reason we want to rewrite it that way is now this part is du, and the rest of it's in terms of u. I'm going to give you a few seconds. I want you to write what the next step is, where everything's in terms of u and du rather than x. So write the next step in terms of u and du, and then don't go further, and check it with me in just a second. So we should get it looking like that because u is sine x. So we get u to the 5th, and then 1 minus u squared to the 5/2, and then the cosine x dx, that's du. Does everybody follow that? Any questions to there? Okay, now I want to stop with this approach for a minute and go down and do the same thing to this other approach. So I'm going to get us started on it, but then I want you guys to get it to this form, and then we're going to talk about which approach is better. So if u is cosine, du is negative sine x dx. So we're going to split off one factor of sine for the du. So how many factors of sine are left if I split off one of them for the du? What do you guys think? 4. So we're going to have sine to the 4th, cosine to the 6th, and then sine x dx at the end. Now I need a negative here, so I need to multiply outside by -1 as well. And now that part is for the du. And now I'm going to give you a minute and actually mute myself for a minute and let you guys try to get it to this step. So do basically the same thing and get it down to here. I'm going to give you a little bit, minute and a half, and then we'll work this together. Okay, so if you're good, keep working. But the idea at this stage is to rewrite this in terms. If you're good, guys, keep working. But the idea at this stage is to to rewrite everything in terms of cosine. So we're going to rewrite sine to the 4th as 1 minus cosine squared, and then cosine to the 6th x, and then times negative sine x dx. And the side work like that over here is that sine to the 4th x is the same thing as sine squared, and then sine squared is 1 minus cosine squared. So we get it to that. So that's over here is what we're doing to go from here to here. Why is that the one that I'm rewriting? So like, why did I rewrite cosine up here? Why am I rewriting sine here? Why are we doing that?
So you can get it in terms of u.
Yeah, we're trying to get it in terms of u. So down here, u is cosine. So when this is already cosine, we don't bother that one. When this one's not in terms of cosine, we need to get it in terms of cosine. So now when we write it in terms of u and du, we get negative integral 1 minus u squared times u to the 6th times du. Does that make sense to everybody? Any questions so far? Now, I want you to think about, we had a test what, last week, right? So test was last week, and this problem and this problem both would have been fair game for the exam. Which one would have been a lot easier to deal with than the other one? What do you guys think? One of them is much easier.
The bottom one.
Yeah, the bottom one's much easier. Why is that one easier than the one on top?
Because you can factor out the 1 minus u squared
Yeah,
to
you can,
squared.
yeah.
Foil it out, I mean.
Yeah, you can multiply out or FOIL out. You can distribute this squared. So you can multiply 1 minus u squared times 1 minus u squared. And it's kind of tedious, but it's pretty easy algebra. Up here, you cannot expand this in any way because this is a fractional power. So what we can do on the second problem, let's finish it, and then let's talk about how we know what to do. So we can expand this and get it to there. Does that make sense to everybody? And if that's not a formula we know how to do, like in our head, you would do 1 minus u squared times 1 minus u squared on the right and like use the distributive property, or some people call that FOIL, but you like distribute that out and we get it down to this. Now we're going to distribute the u to the 6th. So we're going to get negative integral u to the 6th minus 2u to the 8th plus u to the 10th du. And now we're going to split this into 3 integrals. The negative carries with all 3 of them. So we get it to that step. Any questions to there? Now those are all power functions, so we get negative 1/7 u to the 7th plus 2/9 u to the 9th minus 1/11 u to the 11th plus c. That's then negative 1/7 cosine to the 7th x, because u was cosine, plus 2/9 cosine to the 9th minus 1/11 cosine to the 11th of x plus c. And that's actually the answer. Does everybody follow what happened there? Please ask, because I know these are weird and I know we've been at this for a little while. Everybody good? Okay. Okay, now, it's important this approach does not work up here. The approach to this integral would actually be a technique called trig substitution, which we're going to talk about next week. It's as fun as it sounds. You guys will love it. But you do trig substitution, and the problem is that it gets you back to this integral, except instead of theta, instead of x, it's theta. And so it gets you to the integral we couldn't do to begin with, and it's a different variable. So it's not like it cycles back to that integral. It's the same thing, but theta, so you can't even solve for it. So it just would get you to something you can't do anyway. And so this, unless a weird u substitution parts combination will work, this is not going to work at all this way. This problem works well because you had this nice positive integer power here, and we could handle this algebraically. So like, had this been a 2 or a 3 or a 4, or if it had been a 1, this would be easy. If this is a fraction, this is not easy to deal with. Does that make sense to everybody? Okay, so what the key is for this to be a nice positive integer. So you want that to be 1, 2, 3, 4, 5, or up. You don't want it to be 1/2 or 5/2 or 3/2. So what I want us to look at is this problem where we've got sine to the 4th x, cosine to the 3rd x dx. And I want us to think through, okay, which approach works? So should I let u equal sine x and let du then be cosine x? Or would it be better to let u equal cosine x and let du then, or then du would be negative sine x dx? Like the negative is easy to deal with. It's annoying, but you can get it. So which of those approach works, or do both of them work, or do neither of them work? And so the idea is, if we were to do the blue one, u equals sine and du equals cosine, we split it this way. I'm sorry, no negative there. We split it this way. And now, what do we care about as far as whether this is going to work? So there's the du. We now need to rewrite everything in terms of sine. So which power at this stage matters? Which one do we care about, the 4 or the 2? We care about the 2 because that one we need to rewrite. So that is good. And what is good about it? What do you guys think?
It's an even number.
It's an even number. So if that at that stage was 2, 4, 6, 8, then we can rewrite it as 1 minus sine squared to a positive integer. At that stage, if it's odd, that's bad. We don't care about this one because that's u. Does that make sense? Okay, now, if we were to do the approach in red, we would rewrite it this way, and we'd have 3 sines left. We'd have 3 cosines left, and we'd have the 1 sine for the dx. This time we'd need to get to the negative. That's fine. Now, which power do we care about? Do we care about the power on sine, or do we care about the power on cosine if this is the setup? You guys think? So we got to rewrite which of these. We've got to rewrite sine in terms of cosine. And so this is bad because it's odd and we don't care about this. This would mean we'd end up with 3/2 here instead of 5/2, but we'd get a 3/2 power there. So everybody get the idea of what we're talking about? So the answer to that is no for everybody. Some people are getting it, but some people are not. Do we understand what I mean by this?
So you want to make the u the one with the even exponent?
Sort of. The most compact way to say it is that you want to let u equal the one that's not odd. And I know that sounds like what you just said, but if I write this problem, I'm sorry, what I just said is not right either. You want, so what the best rule is if one of them is odd, if one of them has an odd power, u should be the other one. Okay, so if one of them has an odd power, u should be the other one. So here, cosine has an odd power, u should be sine. Here, they both have odd powers. Both setups are going to work. Does that make sense? Now I want us to be able to think that through, because when we get to secant and tangent, you have to think it through. There's not like a quick rule. But the quick rule for sine and cosine is if one of them has an odd power, you should be the other one. So cosine had an odd power here, you should be sine. Back up here, sine had an odd power, you should be cosine. Down here, they both have an odd power, both setups are fine. Here, neither one works. Does that make sense?
Yeah.
Tomorrow we'll talk more about this, but I want to make sure we're done with integration by parts. If you can, get that out of the way before tomorrow. Technically due Monday. So you have 3 now assignments for the week. There'll be a 4th one after tomorrow. They're all due Monday, so you have to pace how you want, but try to get out of the integration by parts stuff so you're not doing calculus all weekend. All right, so tomorrow we'll do more with powers of sine and cosine, and we'll start talking about powers of secant and tangent. That's it for today. If you have questions from the homework or you want to ask other questions, stick around. If not, I will see you tomorrow. Thanks for coming, you guys.